Good afternoon, guys. Welcome. This is the tutorial for Experiment 6, Solubility Rules in Aqueous Reactions, and I am Nan, one of the lab instructors. Thanks for coming in and watching this tutorial with us. So let's take a look at this. Our experimental objectives for this are to observe reactions where a precipitate is formed, to understand the solubility rules, and to practice writing molecular ionic and net ionic equations. Now, as far as our background goes, when we take some mixtures of aqueous solutions, clear, things that we can see through, they may not always be, clear solutions, they may be colored, but we can almost always see through them. When we mix them together, we may not end up with something we can see through, right? We may get something that we can't see through. That means we formed a precipitate, okay, which is a solid that's suspended in that solution, and that's called a precipitation reaction. Okay, I'll show you what those look like in just a minute so that you'll understand what they look like. We can predict if a precipitation reaction will form by using our solubility rules. Now, this is not an inclusive list, but this is some of what we're going to be talking about for this experiment. We have a couple that we want to talk about. The alkali metals, those group 1 metals that we've talked about before. So lithium, sodium, potassium, rubidium, and cesium, group 1 metals. The nitrate ions, NO3-, the ammonium ions, NH4+, and the acetate ions, C2H3O2-, are always soluble. Okay? Our sulfate ions, SO42-, are always soluble, except when they're mixed with calcium, barium, phosphate, silver, lead, or mercury. Halogen ions, those ones that are right next to those noble gases that are always -1, so group 17, so F-, Cl-, Br-, I-, those are soluble except when they're mixed with silver, lead, or mercury. And our hydroxide ions, those OH- ions, are soluble only if they're mixed with alkali metals, calcium, strontium, and barium. Okay, so those are the things that we're talking about for exceptions to that rule. So mostly they're insoluble. Okay. And when we have a precipitation reaction, we can write multiple equations to describe those processes. Now we can always do this when a reaction happens. We can always write these 3 equations. We typically do it most often for precipitation reactions. There are 3 types. One is the molecular equation, which is what we've been writing so far. Everything is shown as a molecule. Okay? We typically indicate the physical state afterwards. So here I have sodium phosphate, which is shown as aqueous because it's dissolved in water. Okay, so sodium phosphate reacts with calcium nitrate, both of which are aqueous, and then that's on the reaction side, and then I produce sodium nitrate, which is also aqueous, and calcium phosphate, which appears. Actually, it doesn't say that up here. Oh, yes, it does. So, oh, no, it doesn't. But calcium phosphate is a solid when we form it. Okay, it's not one of these rules, but calcium phosphate is one of our solid exceptions. Okay, so Ca3PO42 is a solid. Okay, so that's one of those things that we get, and we indicate that is a solid because it makes that solid precipitate. Okay, we can also write something called an ionic equation. It shows all of the species as ions as long as they're soluble. So we have our Na+, which is an aqueous, our phosphate, which is aqueous, the calcium that's aqueous, the nitrate, which is aqueous, the sodium is still aqueous, the nitrate is still aqueous, but that Ca3PO42 is a solid, so it stays together. Since it made that solid, those don't come apart. Okay, so since it's a precipitate, it's an insoluble solid, and so it stays together. Now, chemists are lazy, so we don't like to write all of this stuff, especially since not all of it's involved in doing the interesting chemistry. Some of it's just standing around. And so these things that aren't involved in making this solid, like the sodium and the nitrate, since they're literally just standing around, they're not even involved, we like to leave them out. And we call those spectators because they're not involved in the chemistry. So we can write a net ionic equation that only involves the ions that are involved in making that solid. So we have the calcium and the phosphate going to make that solid. And we've left out the spectators, the ones that weren't involved in making the solid. Okay, so those are the three types of equations that we can write. You're going to get some practice doing that for any of the reactions that we do that make a solid. Okay, so that's our goal, is to do these reactions, see if they make a solid, and if they do, then we're going to write the reactions for them. Okay, now there are no real calculations that we're going to be doing for this, but you will write those equations for the precipitation reactions that you see. Okay, now since this is just going to be mixing solutions together, there are no real new techniques that we have to deal with. But what you're going to be doing is mixing those solutions in test tubes. Okay. So we wanted to show you kind of what that was going to look like, because we don't always form what you might be expecting. We often get people who think that we're going to make a solid and it's not going to look like, the liquids that we started with. So I'm going to show you this cute little video and give you some idea of what these are going to, what we're going to get this to look like. So here's our video. So we start with these nice, pretty clear liquids. And then we add sodium hydroxide to these things. Add NaOH to all of them. So we add that to the iron solution there, and we make this green stuff, right? And then over here, we add that to this particular solution. This is iron 3. We make that brown stuff in there, and that is the formation of a solid. But it's not a solid that's all down at the bottom and it's not like a pellet, but that is the formation of a solid. And now we've added copper hydroxide. Okay, but this stuff that we can't really see through, that is that formation of the solid. Now, if you leave these sitting for long enough, they do change color. They do some other things. This the copper hydroxide does begin to decompose. This one doesn't change at all, and this one starts to change color because it oxidizes. Okay? You have some things that happen to it over time. Okay? So I just want you to be aware that those things do happen over time. So we will get it so that it doesn't always look exactly the same as time goes on. Sometimes these reactions do take some time. Okay, so they may not be instantaneous. You noticed when we were looking at this that it did take some time for these to happen. If this one particularly, we had to take a little bit of time to get that one to show up. Okay, so they're not always instantaneous. The lab manual does say that you need to wait for 3 to 5 minutes for these precipitates to form. So you've got to do these reactions and then wait for them to happen. Okay. So what I typically recommend is that people do all of the, mix them all together and then stand there and wait and then see what happens. Okay. By the time you're done, getting to the last one, you can start looking at the first one to see what's happened. And then you can start writing the equations if you see that there are things that have happened. And by the time you get to the last one, you'll know if it's actually done anything. Okay, so that's my recommendation. Now, do you have to do it that way? No, absolutely not. You need to make sure that you've given everything at least 5 minutes. Okay? So that's what we're talking about for techniques. Now, is there anything else that we wanted to talk about? Oh, one of the other things, make sure that you wash your test tubes before you do these reactions, because if there's anything in them, it can interfere with the reactions that you're trying to look at. I didn't want to start that again. I wanted to go to the next slide. There we go. For safety, not a lot to talk about. You must wear your goggles at all times during this lab. That's always recommended. You should be wearing gloves. It's helpful. Okay. You want to wash your hands after handling the materials in this lab and before you leave. You need to make sure that the test tubes are clean. I just talked about that. And your test tubes should be washed and dried after disposal of the solutions. And there are going to be places to dispose of these solutions, not just down the drain. Okay. So there's that in terms of safety. And things to keep in mind. Remember that when you write net ionic equations, you're eliminating the spectators. And those spectator ions are those that do not participate in forming that solid. They're present only to balance charge, and therefore they only watch. They're not part of that formation. So that's everything I have to talk about in terms of this lab. I mean, there's not a lot you need to be told in terms of what's going to be happening. So I think you guys will be fine. If you have any questions, talk to your instructor about doing this experiment before you go to class. And if you have any questions after you guys are done, please talk to your instructor. Good luck with this one. Have a great time, and I will see you guys if you come to one of my sections. Thanks.